Welcome back. We've created sediment. We've deposited that sediment. Now, let's take that sediment and create sedimentary rocks. Ooh, I'm getting weird. All right, so when we take sediment and create sedimentary rocks, that process is called lithification. Lithification. So you're taking loose sediment, transforming it into sedimentary rocks. The root lith comes from the, I believe, Greek word lithos, meaning stone. It's a three-step process: sediment deposition, deposit sediment, compact it together, compaction, and then you got to cement, you got to make it all stick together, cementation. So we talked about sediment deposition in the previous video. Remember, most of the world's sediment, thus sedimentary rocks, form in the shallow oceans. Not always, most. For example, I can tell you right here that this isn't oceanic sediment deposition. This is actually Aeolian sand dune deposition. So that'd be on land. So, but most of the time, shallow ocean. So how does this process work in any case, whether it's sediments deposited on land or in the ocean? How do we lithify sediment to sedimentary rock? You compact it together, squeeze it together, and that just comes from the weight of overlying sediment. You pile more and more and more stuff up. The stuff on the bottom is going to get squished together. So as you squish it together, you're reducing the pore space, the space between the sediment. When you're doing that, if there's water, even at the molecular level, in between these small pieces of sediment, they really get driven out. As that water kind of gets expelled out, it might leave behind any material that's has been dissolved in the water, leaving behind different minerals that form natural cements that kind of bind all that material together. So compaction and cementation. There are three types of sediment: biogenic, chemical, and clastic. And those three types of sediment makes the three different types of sedimentary rocks: biogenic, chemical, and clastic. Go figure. Before we do, let me give you another part of the super secret code. Is the number 2. The number 2. One more time, the number 2. So biogenic sedimentary rocks are just like biogenic sediment is, composed primarily of plant and animal remains, and include minerals created by organisms. Some common biogenic sedimentary rocks. These are just a couple of examples. Coquina, which is usually a lithification of seashell material. Coal is a sedimentary rock. It's the lithification of plant-rich, organic-rich sediment, remains of leaves, twigs, logs, wood, that kind of stuff. So here is coquina. You can see the little pieces of shells that were compacted and cemented together. It kind of looks like a weird Rice Krispie treat. And then here's coal. Coal, you can actually see the layering, that's the layering of dead plant material that's been squished together. Those are just two examples. Chemical sedimentary rocks come from chemical sediments. It's the result of lithification of chemical sediments formed by the evaporation or precipitation processes. So think back to chemical sediments. So you have water with a bunch of stuff dissolved in it. The water evaporates away, leaves behind that material. That material kind of layers itself up. If there's enough of that over time, compaction and cementation can occur. Some common chemical sedimentary rocks: rock gypsum, rock salt, limestone. Calcite's the main mineral in limestone. Limestone, is the kind of precipitation of calcium-bearing minerals, typically in lakes or oceans. So here is rock gypsum. Here is limestone. And then finally, clastic sedimentary rocks, formed from the lithification of clastic sediments, rock fragments. In these, they're kind of easy, a little bit more easy to pick out, and when we get into the lab, most sedimentary rocks we'll identify will be clastic in nature. Most sedimentary rocks you would see around where you live in Arizona are clastic sedimentary rocks. A lot of times you can really feel, or sometimes even see, the pieces, the clasts. They feel gritty, or you can see different pebbles in there. Sometimes, if you're not sure, one test for a clastic sedimentary rock, kid you not, is it feels gritty, but you're not sure. Put it in your mouth. Kind of move it around your teeth a little bit. If it's even a little bit gritty, your teeth will feel it. I get the shakes thinking about it because I've done it so many times. Oh, all right. So examples include conglomerates, which are consisted of lithified, larger round gravel-sized clasts. Breccia, large angular, more sharp gravel-sized clasts. Sandstone, it's pretty gritty, dominated by quartz grains. Sand, it feels like sandpaper. Mudstone, a little bit less gritty because it's made of smaller clasts. A little less gritty, but sometimes it's lumpy. Shale, it's the least gritty, made up of small clay-sized particles, and it's layered as an indication. Again, these are just some examples so you can see the class. Here's a conglomerate. You can see these rounded pieces of rock fragments cemented together. And here's sandstone. It looks like a bunch of sand that's been compacted and cemented together. Again, just some examples. We'll look at a lot more of these in lab. We'll pause there. When we come back, we'll tackle our last section and talk about sedimentary structures. Sometimes within sedimentary rocks, we see these structures that help tell a story, help tell a geologic story, the geologic history of an area. If you remember back, I said in Unit 5, when we're first introduced to sedimentary rocks, me personally, they're not much to look at. They're not my favorite, but they do tell one heck of a good story. And we'll talk about that in our next video. I'll see you back in just a minute.